As you design and expand your Azure environment, you often need multiple virtual networks to support application isolation, multi-region architecture, or organizational boundaries. But what happens when these networks need to talk to each other? That's where virtual network peering becomes your go-to solution. Virtual network peering connects two VNets, enabling them to communicate as if they are on the same network. It's low latency, high bandwidth, and uses Microsoft's backbone infrastructure. No need to route traffic through the internet or VPN. Once peered, resources in each VNet can communicate using private IPs just like they would inside a single network. Peering is non-transitive, meaning if VNet A is paired with VNet B and B is paired with C, A cannot communicate with C unless A and C are also directly paired. When you're planning to connect virtual networks in Azure, understanding the difference between regional and global peering is key. If both your VNets live in the same Azure region, say East US, you're looking at regional peering. This option ensures traffic stays within that region using Microsoft's ultra-fast regional backbone network. It's perfect when you're working with microservices that need to talk to each other, want to segment environments securely, or just need clean workload isolation. But what if your VNets are spread across different regions like East US and West Europe? That's where global peering comes in. You're still riding on Microsoft's backbone, not the public internet, which keeps things fast and secure. Global peering helps you support multi-region deployments, ensure high availability, and meet compliance needs without sacrificing performance. Sure, it's a bit more expensive than regional peering, but it's still significantly cheaper and more efficient than using VPNs or express route for cross-region traffic. Now, let's talk about encryption. You might be wondering, is traffic between paired VNets encrypted? By default, it's not. But don't panic. This doesn't mean your traffic is flying around the internet. It's still traversing Microsoft's secure private backbone, which is compliant with enterprise-grade security standards. For most internal workloads, that's more than enough. However, if your organization requires encryption in transit due to strict compliance or security policies, you've got two solid options. First, you can set up a VPN gateway between VNets. This wraps your traffic in IPsec IKE encryption, but it also adds a bit of complexity, latency, and cost. The second approach is to encrypt at the application level using TLS or similar protocols. This is more granular and performance-friendly, especially for app-to-app communication. Just remember, solutions like private link or express route encryption don't apply directly to VNet peering scenarios. To wrap it all up, here are some tips to help you design VNet peering effectively. Peering is bidirectional, but you still need to configure it on both sides, unless you are using the portal's handy auto-create peer feature. Use network security groups to filter traffic between VNets. If you want shared connectivity, don't forget to enable gateway transit. And in large environments, stick to consistent naming conventions and resource tagging to stay organized as you scale. With smart planning, VNet peering gives you a powerful way to build seamless, secure, and scalable networks in the cloud. So, what's your key takeaway? Virtual network peering is one of the most powerful tools in your Azure architecture toolbox. It connects your VNets without the overhead of traditional networking, supports regional and global expansion, and gives you flexibility in designing secure, high-performance environments. Just remember, if you need encryption, you'll need to layer it in either at the app level or use VPNs.